Hello and welcome to some review for Statistics 1. The list I'm going to be going through today are covering some of the requests of your classmates. So I'm not going to be doing everything, just what was emailed to me. So if you were lucky enough to get email in of some review stuff, this is for you. Hint, hint, wink, wink, and I think you know who you are. Anyway. I apologize if you hear some of my breathing on this video because the mic I'm using is not as nice as the one I normally use. Yeah. And in order to get it to pick up my voice, it's got to be like pretty much in my mouth. So I'm sorry if this one's annoying to you. Anyway, so the questions we're going to talk about today are number 14, number 15, 16, 18, 25, and 27. So if those made your list of I want to see those, then that's definitely the ones we're going to be doing. So the first one we're going to look at, I flat out tell you, is a binomial. If you haven't read the question, you should do that before proceeding through what I'm about to do today, or maybe give it a little bit of a try on your own before we attempt them today. So since this is a binomial, I'm going to be using Minitab to calculate the probabilities because, as you can see as you look at each of these questions, it's asking about probability. This is not to say you couldn't do these by hand. I'm just going to choose not to. So the first thing it asks you is what's the probability that two or more of the individuals in the sample of 25 have the type O negative blood. So two or more means two or greater, so greater than or equal to 2. So we would do that on Minitab using graph probability distribution plot. We always choose view probability. We're going to change this from the normal to the binomial, which is going to be near the top since it starts with a B. The number of trials, there are 25 individuals in my sample. The event probability, this is always your probability of success, which for us is going to be having type O blood, and that's 7% of individuals in the United States at the time that this question was written. Then I'm going to click over to shaded area. And like I said, I want 2 or more that have type O blood, so greater than or equal to 2. So I need to change this to value, not probability. You're always inputting into Minitab what you know, not what you don't know. Since I want probability, I want to know what it is. I don't know it, so I'm going to be giving Minitab what I do know, which is a value. So I do know that I want 2 or more, so greater than or equal to or to the right of 2. Let's put 2 in there, and then go ahead and hit OK. And there's our distribution. It looks like the answer to that is 0.504. Good times. Okay, so the next question is, what is the probability that fewer than 3 of them have type O negative blood? So fewer than 3, less than 3 is what this is. Less than 3 is the same as less than or equal to 2. Remember, when we're thinking about Minitab, we have to be using equal to's to be able to do these questions. So a common mistake for this might be thinking that it's the opposite of A, where A is 2 or more, which includes 2. But when you think of things that are fewer than 3, that has 2 in there, since 2 is less than 3. So since they would both share 2, it's not exactly the opposite. It's not these blue squares. Or, sorry, rectangles. Those are definitely not squares. Who teaches math? Well, not geometry lately, evidently. So let's hit the white Let It Last dialog box. We're going to go over to shaded area, and this time, since I'm not going to the right, I'm going to the left. So you notice how it's that little gray area right there. I want 2 or less, which is this one, or also known as fewer than 3, or less than 3, which is less than or equal to 3. And there is our value, 0.7466. So that's B, which was specifically requested by our grouping. For fun, let's also do C, because I can do C really quickly right now. It says, what's the probability that none of them have type O negative blood? And the sort of like quick and dirty way to do this, or easy, I should probably just say easy instead of quick and dirty, is that if you look at this, you already have a graph of all the boxes. And hopefully you remember that in Minitab, if you leave your mouse hovered over a box, it'll give you the probability. And so since C is, hey, what's the probability that none of them have type O negative blood, you can just leave it sit there, and it literally tells you what 0 is. Good times. It's probably good that this question is later. You can skip around in your questions. So if you have a couple equal to's showing up, go do one of the greater thans or less thans first, or less than or equal to's, and then just leave your mouse sitting on top of your graph to get your equal to's. Alrighty, let's have a look at some of the other ones we can have here. So D, what is the probability that's between 1 and 3 inclusively? Inclusively means that it includes 1 and 3. So I'm going to hit my edit last dialog box, go over to my shaded area. When it's between two values, you always use middle. And since it's including 1 and 3, those are going to be my cutoffs. I just put in 2. Let's throw 3 on there and then hit OK. There we go, 0.7434. Good times. The next two questions, which is E and F, woohoo! What's the mean and what's the standard deviation? These are both coming from the normal approximation to the binomial, which you may know the mean is P times N, or the probability of success times the number of successes, and it's 1.75. And then the standard deviation is the square root of 0.7 times 25 times 0.93, which is NPQ. So there's how to do those two. That was kind of fast. Let's move on to number 15, specifically A through C. This is also a binomial scenario. Since I have some type of success, the probability that you are going to get divorced in your second marriage. This one's a little depressing, but at the same time, I just needed something that had this type of scenario, so I don't know, judge me. Out of 20 couples who are just got married for the second time, then we've got some questions. Find the probability that fewer than 9 of the couples will be divorced. So fewer than 9 corresponds to be less than 9, but remember Minitab takes only less than or equal to's. So this is going to be the same as less than or equal to 8. So that is what we will be calculating in here. So we're going to hit the edit last dialog box since we just did a binomial. And I'm going to change my scenario. So I have 20 couples. That's my number of times we're going to try to stay married. And the probability is, oh no, wait, I'm trying to be divorced now. Oh, this is just the worst question. 0.67, probability to divorce. Woo, woo, woo. Yikes. Let's go to shaded area. Okay, so like I said, this first question is fewer than 9, which is the same as less than or equal to 8. So I'm going to be putting 8 in for my value and doing a left tail, since less than on the number line corresponds with being to the left of other values. Let's go ahead and hit our OK. Wonder how this one's going to look. Ooh, that one's a little cuter. Almost normal looking, isn't it? Ooh, that's small. Ooh, that's small. Not very many are going to get divorced. Well, I mean, this proportion is not as likely, or this number. Let's see if we can find the probability that exactly half of the couples will be divorced. So exactly half would correspond to 10 out of 20. So I can just leave my mouse on top of 10. Ooh, I got to click into Minitab first. And there is the value, 0.0515806. Since I've done one similar to this before, I'm going to show you another way to do this. If you want to, you can also do this using the Calc menu. So we can go to Calc, Probability Distributions, into the Binomial. And then you have to change this from cumulative probability to just probability, because you're just doing one value, exactly half, or 10. Put in my number of trials, which is 20. My probability of success, which is 0.67. And then we're going to input a single constant of 10. It's just another option on how to do this. And then go ahead and hit OK. And there is the exact same value for you for funds. Yay, marriage. I don't know why this question. Yeah, it is what it is. Yep. Okay, so that's B. Let's see if we can find the probability that more than 12. So here's the thing. More than 12 might not necessarily include 12. So more than 12 would be like greater than 12, which is the same as greater than or equal to 13. So that's what I'm going to do. And I'm going to do it using the graph again. So I'm going to go to Graph, Probability Distribution Plot, View Probability. And I'm still in the binomial, still the same number of trials, still yield 0.67. I'm going to do a shaded area. And now I want more than, not less than. So it's not a left tail, it's going to be a greater than. And I want more than 13. So remember, greater than or equal to every time. Go ahead and hit your OK. There we go. And that would be our value right there, 0.6732. Oof, I can read. Which seems pretty reasonable since 13 is pretty much at the center of the distribution. It makes sense that if you go to the left of the very center, you get almost half. If it were perfectly symmetric. This one does not look perfectly symmetric. It's got a slight skew to it. Alrighty. Where am I at? I have lost track. 15, I just did C, and she only requested A through C. So I don't know if I should do D, E, F, or G. Well, these are all pretty similar to to 14, so I don't think I'm going to do all of them. Her next request is to do 16, just C and D. We'll see how this looks. What's the probability that there are less than 2 lefties in the group? So less than or equal to 1. What is the probability that there's less than half are lefties? How many are there? 10 customers. Left-handed, 13%. Okay, let's get her done. Oh, I can't believe I said that. Judging. Let's do this. That's slightly better. So now we're looking at lefties. Still binomial. Now there's 10 of them. And only 13% are lefties. That seems a little high. I think it's actually smaller than that. You can actually get a scholarship for being left-handed. Fun fact. Maybe go apply for that. Now I don't know what I'm doing because I didn't really pick a question. So we're looking at a sample of 10 customers in the store. We want to see how many of them are left-handed. So what's the probability that exactly 2 are lefties? I don't want to do that one because it's an equal to and I can get it off the graph by just putting it in there. So I think I'm going to do B. What's the probability that there are at least 2 lefties? At least 2, which is the smallest it could be is 2. But there might be more than 2. At least 2. So if you're thinking about this, it's like, oh, I need at least 2 quarters to be able to call home. That means if I have 2 quarters, I'm good. If I have 3, I'm good. If I have 4, if I have anything bigger than 2, I'm good. But if I have under 2, I can't make my call. So it's got to be the smallest it gets is 2. But bigger than that is fine. So I'm going to do a right tail for that because this is corresponding to greater than or equal to 2. Let's throw 2 in there. Hit our OK. And there's where we're at. So there's greater than or equal to 2, and it's 38.04%. Similarly, if I want A, which is exactly 2, I can leave my mouse sitting on 2 and get that the probability is 0.249605. Doing okay with that? I don't know. Yeah. So you can also use this to do C, which is there's less than 2 lefties, which would correspond to 1 or smaller, which would be 1 and 0, which would be these two. So you can do 1 minus to get the 1 minus 0.3804 to get C. D is interesting. What is the probability that less than half are lefties? So if there's 10 of them, half would be 5 or less. I bet you that's going to be almost everything. Let's find out. So let's hit our edit less dialog box. Here I want to go to the left of 5, because less than half. Ooh, less than half, not less than or equal to. Ooh, I got to do less than 4. Yeah, because it could be 4, 3, 2, 1, or 0 that are lefties, and that would be less than half of them. Let's see how this goes. Glonk. Ooh, it's like everything. Well, it's pretty much everything. 0.9947. So that's like everything. Pretty much everybody is not left-handed, which isn't too shocking since it's only 13% of individuals. Okay, so probability that they're all right-handed. That's 0 lefties, so you can leave yourself sitting on box 0 to get that. And then how many lefties do you expect? That's finding the mean. Remember, expected value means mean. So I just do 10 times 13%, or 1.3 lefties in the group of 10. So 1 is probably the most common. And hello, look who's the tallest box. It's 1. Fun fact, it matches. And if you had 100, how many would you expect? So you would just multiply this by 10 again to get 100, or multiply 100 times 13% to get, well, 13 customers out of 100. Shocking, right? 13% is left-handed, 100 of them, 13 are left-handed. The mean makes sense when you think about it. Okay, let's skip ahead to number 18, because that's her next request. The time it takes the driver to react, I said I wasn't going to read these. 18. A standard brake light is modeled by a normal distribution with mean of, standard brake lights are modeled by a normal distribution with a mean of 1.25 seconds and a standard deviation of 0.46 seconds. What proportion of reaction times will be between 1 and 1.5 seconds? So this is said to be normal. It's given that it's a normal distribution. So that means when we go to our mini tab, we want to use the normal. So we're going to go to graph, probability distribution plot, view probability, hit OK. We're going to change this to the normal. Now we got to change our mean up. Our mean is 1.25. Our standard deviation is 0.46. I'm going to go over to shaded area, And they want to know about between 1 and 1.5. That's a middle. I'm going to change this to match. Okay. And this looks good to go. Let's hit OK and see what our probability is. 0.4132. Ah, I see why this was asked, because I have a feeling, if I remember, I changed this problem, and then that caused the solution sheet to be incorrect. That's probably why this one's being asked. Okay, let's do B just to make sure we're good. So if you're traveling 70 miles per hour, your car will move 103 feet in 2 seconds. Well, for a specific car, this will happen, roughly. Different cars, different stopping times. What proportion of reaction times will be less than 2 seconds? Ah, 2 or smaller. So it's probably out here, and then to the left. One of my pro tips for these questions is that if you're not sure what it should look like when you just read the words, try drawing it. So draw your normal distribution with its mean and its standard deviations. Locate these values, like 2 seconds, and then sketch in and color in the 2 seconds or less, because then when you produce your Minitab graph, they should match. So I'm going to do left tail, or it helps you pick left and right too. In 2 seconds, let's see how we be. It appears to be 0.9485. Yeah. Yeah, I'm going to have to go back and change the solution manual, because that one, I remember it being something like 0.7 or something. Yeah, I must have changed this question. I'm sorry if that was the reason why you asked this one. Individuals who asked me to do stuff. I laugh because of my failure. I found other typos in this too that I'm going to correct today. Hopefully that'll make y'all happy. Like, I found a part where my, in the review session, where my answer to the hypothesis test conclusion was like 1 line. That's not good enough. I can do better than that. I will definitely improve it. I must have been tired when I was doing this. I don't even remember doing some of it. Hey, let's do 25 now. Good times. And a recent study for the Center for Disease Control and Prevention reports that the systolic blood pressure for adult women in the United States, I'm reading again, aren't I, has a mean of 80.5 and standard deviation of 9.9. The researcher wishes to select women from the study, but wants to exclude the bottom 10%. So they want people who aren't really, really low in blood pressure. What would be the upper and lower reading to qualify to participate for the study? Oh, top and bottom 10%. Ah, okay. Cool, cool, cool. So, where are we at? So if I want to exclude the top and bottom 10%, this is relatively normal. Yes, yes, yes. Normally distributed. Yep. Okay, cool. Let's go to our graph. Normal. Mean of 80.5. Standard deviation of 9.9. And let's see, where are we at? Top and bottom 10%. Oh, I bet you I know where this was confusing. So it's a little bit from the wording where you might think, oh, the top and the bottom together, do they make 10%? Or do I want to remove the top 10% and the bottom 10%, which is how I would interpret it. So you might want to look at this and be like, okay, I want to do middle. Oh, I got to do probability. What am I doing? I want to remove probability. I want to remove the bottom 10% and the top 10%. So those guys. And I bet you this is where things were getting a little confusing. Yeah. There you go. So now it's the middle 80% because 10% in this tail, 10% in this tail, so 10% in the lower, 10% in the upper, and that gives you the cutoff values. So 67.81 to 93.19. Good times. So that's 25. Next up was 27. Let's see. Ooh, a confidence interval. I like those. So let's see. How many people do we got? 635 of them were dropped or dismissed out of 1,228 lawsuits. Let's build ourselves a 90% confidence interval. Yay, 27. Alrighty. So let's go to not graph. We're building confidence interval. Ah, this will be a proportion test because I'm counting stuff. All right, so I went to stat. Oh, that's loud. Okay, stat, basic statistics, proportion. Since I don't have data in a column, I'm going to be using summarized. Number of events I'm interested in is the 635 that are dropped out of the 1228. And I want a 90%er, so I better check my options and make sure that's correct. Remember, with the proportion, it's incredibly important that you change the method from normal to exact, and that's about the only thing you have to make sure you do. Well, I mean, you have to do for all of them. For confidence intervals, your alternative needs to be a not equal to. And then the last thing you want to check is the level of confidence, which for 27, we want a 90%er. So I got to change this to 90%, and then hit OK. And that looks good. So let's hit OK again and see what we get. And there is our confidence interval for proportion. So it looks like that the number of medical malpractice lawsuits that are dropped or dismissed is somewhere between 49.4% and 54.1%. Good times. And that's all I have from requests from the individuals who were unable to make it to review today. So if you had other requests, don't be afraid to ask and or come ask me questions in office hours as exam week approaches. That's all I got.